So today we're going to talk, first of all, why add large language models in a search pipeline? So why should we do that? Then the second step is selecting the large language model. So how can I choose the right large language model for my problem? How does that search change? So will this affect my search pipeline? How large language models fit in a search pipeline? And how I can measure success. So how can I realize if I'm doing well with this integration or not? And we're going to talk also about some rabbit holes you may find in the process. So let's start briefly with an introduction about artificial intelligence and large language modeling. So artificial intelligence is like a huge umbrella for a lot of techniques in information technologies. Specifically, everything that tries to mimic animal/human intelligence can be considered artificial intelligence. And then we can have like subset of this area with what we know as machine learning. So a subset of techniques from artificial intelligence, which mostly use statistical methods to have like machines learning from experience. And we can go even like deeper in this taxonomy, and deep learning is a subset of machine learning using deep neural networks. And we can have large language model within deep learning effectively. So most of large language models nowadays are based on transformer architecture, and they are pre-trained on huge quantities of text, like internet scale big quantities of text, to effectively learn to predict the next token or to predict a missing token, a missing term in a sequence of terms. So it's like an incredibly powerful auto-completion system. And effectively, it estimates the probability of the next word. So what will be, according to what we have in input, what's the probability of having this other term in output? Effectively, a large language model learns the statistical distribution of terms and sequence of terms in a language. But in general, we don't use just large language models as pre-trained items, but we fine-tune large language models for specific tasks. And in search, these tasks could be query expansion, for example. So we could fine-tune a large language model to be able to predict different ways of rewriting the same query. In general, the vocabulary mismatch problem is a huge problem in information retrieval. So sometimes the terms in the query and the terms in your corpus don't align. So you may have like in a query about tigers, and in your corpus you are talking about Panthera tigris, which is the scientific Latin name for tiger. You could look for sometimes ambiguity. So you may look for an apple as a fruit or Apple as a company. So understanding the context of the query and expanding the query to different forms is something that large language models can do quite well because they've seen a lot of text. So they are able to represent this text and expand a query. It's not the only way we can use large language models. And as I said, of course, you need to fine-tune these large language models. So you're not just using the huge, powerful auto-completion you get from large language models, but then you need to operate additional training effectively to be able to perform these tasks. Another way that large language models can help you in your search project is through retrieval augmented generation, which is known as an acronym as RAG, has been hugely popular recently. We're going to see more about this in the second talk from Enrico. But in general, what it means to generate an answer for an information need using a first stage retrieval of documents from your context, build this context, and then ask to a large language model fine-tuned for instruction-based interaction to respond to that information need in context. So this can solve the problem we've seen playing with ChatGPT. How many of you have played with ChatGPT in the last year since it got released? Everyone pretty much? Okay. So initially it was pre-trained up to September 2021, something like that. So if you were asking something more recent, you couldn't get any sense out of it, right? With retrieval augmented generation, you do first a retrieval stage on your search engine, and then you give a context that can be very up to date to the large language model. So it doesn't matter anymore that the large language model was pre-trained on a subset of reality, because you are passing new information and the ability of representing the language. I'm not using understanding because it's not like we humans understand language, but it's a sort of representation can be used on the new context to effectively respond to the user query. And finally, what's been mostly used, I mean, these are just the three main ways of using large language models with search. There are many others, but neural and vector-based search is probably the third most popular way of interacting, and specifically using large language models to encode text to numerical vectors and then run top K retrieval on those vectors. So you encode the text to a vector in a certain dimension in a vector space. You have your documents encoded in the same vector space, and then you look for similar vectors in terms of distance. Could be like Euclidean distance, can be cosine distance, whatever matches with your needs. So now that we have an idea of why we should use large language models with search, how should you start? So there are many, many large language models available in the open source landscape. Many of them are being released right now. I mean, it's like a continuous progress. Many companies release commercial version of large language models and then release open source version of the previous one potentially. So it's like a very complex landscape. There are various repositories that are growing and growing. So you should start from one of these repositories, such as Hugging Face, for example, and do a filtering based on your domain. So first of all, it could be a legal filtering. So can I use this large language model, so according to its license, with my necessity? So maybe I have an e-commerce, maybe I have like an enterprise search engine. So can I use the large language model for commercial purposes? And then, depending on the domain, among the ones that are compatible from the point of view of the license, which one should I choose? So am I talking about like e-commerce, product search, or news search, or medical search? Depending on that, you may choose one or another. And finally, can I use the large language model out of the box, or I should perform additional fine-tuning? So the large language model that is legally compatible is okay from the domain perspective. So it was pre-trained on a corpus of news, for example, and you have a news search engine, but potentially is a news search engine from American newspapers. So maybe it's potentially in Italian, because maybe you have been translating those articles, but would it be okay for an Italian newspaper where we have like completely different kind of legal articles or politics stuff that are completely different from the United States? So a lot of difference in terms and concepts. So you may require additional fine-tuning. And there are various repositories. So I'm going to share these slides so you can play with them and download stuff and play with the links. But in general, I would say the Hugging Face open large language model leaderboard is probably a good starting point, because Hugging Face is maintaining effectively a leaderboard that they update day by day, running tests on the large language model that have been released in phase. So you can take a look. And normally, I mean, pretty much all the biggest players release large language models in Hugging Face, so it's a good probably place to start. Some of them that you may have heard of, Llama, and then fine-tuned version of Llama. So Llama is from Meta, but we have like various fine-tuned versions, alpaca, vicuna, all these nice South American animals. I don't know why they decided to go with that. I mean, initially I think it was just an acronym, and they went like all in with all these funny, fluffy animals from Peru and nearby, and many others. So I wrote an article on our blog back in June. You can take it as an inspiration for taking a look to the various open source large language models. So the one I mentioned so far are generalists, so are not specifically fine-tuned for specific domain, nor pre-trained on specific domains. You find the dataset from where they were pre-trained in the detail page on Hugging Face, so you can literally take a look to the datasets used for first pre-training and then fine-tuning. We have, of course, like specific large language models pre-trained on specific datasets. If you're interested in biomedicine and science, for example, we have mole former for molecules, nucleotide transformer for DNA sequences, or evolutionary scale modeling for proteins and protein folding. In the biomedical landscape, we have BioGPT, Biomed LM, that previously was known as PubMed GPT, and Gathertron. And finance, we have Finbert. There is a GPT model fine-tuned and pre-trained by Bloomberg that has not been yet released as open source. I don't know if it's going to be released as open source, but I couldn't include it because it's like in a sort of gray area, not yet open source. So Finbert is similar, of course, probably not as advanced as the Bloomberg GPT one. And from the legal perspective, we have LegalBert, for example. And how can you interact with large language models in your search product? So you can start on premise potentially, but you may not be able to, I mean, you may need to spend a lot of money to have like the infrastructure to service such big large language models on your servers. So other options is like, okay, I'm going to just rent machines and VMs in the cloud, such as we've seen in the presentation, I mean, in the introduction from Huawei Cloud, right? So you could use like the Elastic sort of EC2, ECS version from Huawei to run virtual machines and then run services like for large language model inference. So for inference, I mean, when you effectively set up, spin up a service that is able to use a large language model to process an information need and respond. So normally like responding to a prompt, which is pretty much a query. Or potentially you may go with solutions as a service. So there are already like services specifically designed to host some models, such as pretty much the one that ChatGPT uses from OpenAI. Azure is servicing like this sort of REST endpoint. So, you don't care about the machines behind, the VM behind, you just use the inference endpoint, you pay a fee, and you get back the response. And you can integrate these endpoints in your search engine. So what about the search engines? So how do currently open source search engines support large language model integrations? So Apache Lucene has a limited support for large language model integration. Effectively, right now, the only thing that supports is vector-based search implementation. So the ability of looking for similar vectors to an input one. So you give an input a vector in a dimensional vector space, and you get back top k closest vectors. Apache Solar is currently providing vector-based search as well. And soon we are going to have a neural highlighter, which has been developed by us, actually. So we are working on this project. And actually, Elia from our team is leading the project. So if you want to talk about this later, he's here. And is basically using large language models to highlight context in the response. So in the response, you have different results, different search results. And like you have like the snippets in Google that highlight a part of text from the document, and not based on the lexical match, but on the meaning, so on the effectively on the understanding in terms of the language representation for that text. Elasticsearch implements vector-based search, and it also released recently for the enterprise version of Elasticsearch, the Elasticsearch Relevance Engine that use like sparse learn retrieval, and also some support for large language modeling to do mostly neural search. The same for OpenSearch, which recently released also some additional integration for doing retrieval augmented generation, and also Vespa, which is a search engine from Yahoo. So we are going anyway to do like a 5 minutes Q&A at the end of the talk, so both from the remote audience and the in-presence audience. From the perspective of vector databases, there are various players in the open source landscape. I would like to quote here Milvus, which offers vector-based search, Weaviate, which offers both vector-based search and generative search, so retrieval augmented generation, and various Weaviate modules, which are like sort of plugins that you can use for effectively implementing various integrations. And Quadrant offers vector-based search, and Quaterion, which is a fine-tuning framework. So it gives you the ability of fine-tuning your large language models. So we've answered already this question about how you do the process of selecting the best large language model. So let's take a look, for example, of how a search pipeline could change if you want to use large language models to encode text to vectors and then search among those vectors. So you're going to fine-tune a large language model in sentence similarity. So the ability of measuring how similar two sentences are. So when fine-tuning a large language model in this way, you're going to effectively adjust the internal functioning of the large language model to be able to encode the text to vectors in a way that vectors that are close in meaning are closer in the vector space. And to do this fine-tuning, you need to provide pairs of query and relevant documents, and the same query and unrelevant documents, and specifically in a way that we have like close sentences and far away sentences in terms of meaning. So you provide all these samples. They can be like manually generated or potentially like artificially generated. You fine-tune the model, you get the transformer that is able to encode text to vector. So your pipeline, your indexing pipeline, will change in this way. So you get documents, and each document content, and for documents, I'm talking in general about both textual or text plus metadata documents. And you're going to encode each of them to a numerical vector in a specific vector space. So it can be like, I don't know, 768, for example, dimensions, more or less. It depends of the model you use. And then you index these vectors. And normally, the search engines nowadays are going to do approximate nearest neighbors search. So you're not going to do exactly the vector distance between each vector in your corpus and the query vector. You build an offline data structure that is able to approximate the distance relation between different vectors and be used quickly at runtime. A potential approach is using proximity graphs, for example, where you have like an offline data structure. The most used nowadays in the open source landscape is hierarchical, navigable, small world graphs, which use like a multi-layered graph representation to represent distance between vectors, and specifically each node is a vector, and an arc between two vectors means that the two vectors are close in terms of distance. And this is how your search pipeline changes at indexing time. At query time, you take your query, you encode your query to a vector in the same vector space, and then you run a KNN search. So you effectively interrogate the data structure you've built previously at indexing time to look for the closer neighbors to the query vector in your corpus. Now, how you can effectively decide that integrating a large language model in your search system has improved your search at all? So indeed, to be honest, we don't have much differences in comparison to what you do normally, like evaluating your search engine. It's something you should do anyway, even with a lexical search engine, to be honest. So you should do both offline evaluation and online evaluation. So you should focus on what are the most interesting aspects of your search engine. So maybe you have an e-commerce and you want to optimize click-through rate of your e-commerce. So you want to return results that are more likely to get clicked. That's fairly reasonable from an e-commerce perspective. Or maybe you want to optimize the amount of items that is added to cart and finally sold, potentially. And for a news search engine as well, could be clicks, could be downloading a news article, could be adding to favorites, sharing the news article. So a good way is to use this information, this user interaction, potentially ask for feedback, direct feedback to your experts. So you may ask like to your domain experts, so your like phone e-commerce search experts, like what's relevant for a specific query and what's not, and then use these ratings to assess if your search engine, after the integration with large language model, is returning more of the good thing or less. And of course, I'm not talking about just trying and clicking around, but using like specific metrics such as NDCG, normalized discounted cumulative gain, for example, or expected receivable rank. There are, of course, in the literature, various metrics to use for this evaluation offline. And online, you should monitor your search engine, monitor again like the interesting aspects, so clicks, add to cart, downloads, and everything, and check how your users, which in the end is probably what you care the most, are seeing as a benefit. And this, of course, must be done in the short term and in the long term, tracking the delta between like different releases, and in general to measure the success of these initiatives. So what are the main problems you may face during this journey? So you may not measure enough, for example. You may choose the wrong technology for your problem, or you may choose the wrong large language model for your problem. So the first problem is like, how can I measure if I'm bringing improvements to my search system? And the first rabbit hole could be like, okay, you don't measure it offline, you don't measure it online. So the new system is just evaluated based on vibes and feelings. So your CEO tries it and he's, oh my God, it's amazing today. In 1 week, it's terrible. And it didn't change at all, right? So you may realize about problems in your process too late, or anyway, you may waste a lot of money because you may go live with a system that is not really doing well, except for few examples. So always do offline and online evaluation. It's expensive at the beginning, but it can save you a lot of money and time, especially. In terms of the technology, of course, it's super important. Sometimes you want to go all in with the technologies you have already in place. I always recommend like explore, and potentially if you need to introduce a new technology, do it, it's better to do it at the beginning and do like a POC, some experimentation that just go with what you have and then realize that actually you needed something else. And I'm talking about not only the large language model itself, potentially the search engine you're using, supporting that language model. And finally, the models we use. So spend a lot of time choosing the model. So investigate the available models out there, the one that covers the most your domain, the one that has been fine-tuned the more closely to your domain, do experiments, assess on your data which one is working the best, and then go, like to dev, QA, and finally to production. Because also in this case, you may risk to waste a lot of time because you may go live with a model and then realize actually it's doing pretty badly on your data and you need to go back to the process. So you will find like what I mentioned pretty much like encoded in text in this slide. So I will just give a summary of what we've been talking today. So why are the large language models to search? So we've seen the benefits it can bring. So what should be the process of selecting a large language model for your search system? And how does a search system change? Finally, we've seen why it's important and how you can measure the success of this initiative and what can be like the most perilous rabbit holes you may face in the journey. So if you need help implementing large language models for search, we do any kind of services for our client, from project management, engineering, direction and supervision, and also design and development. So we've been working on various POC, integrated large language models for some of our clients, and we are happy in general to help you on this.